In this video, we'll explain how to determine if an equation is balanced or not balanced. When working with chemical equations, it's crucial to understand whether they are balanced or not. A balanced equation represents a chemical reaction where the number of atoms of each element is the same on both sides of the equation. So, what exactly is a balanced equation? A balanced equation is a chemical equation in which the number of atoms of each element on the reactant side is equal to the number of atoms of that element on the product side. Balancing equations is important because it ensures that the law of conservation of mass is upheld, a fundamental principle in chemistry stating that matter cannot be created or destroyed in a chemical reaction. To determine if an equation is balanced, we need to first identify the reactants and products. The reactants are the substances that are present at the beginning of the reaction and are written on the left side of the equation. The products are the substances that are formed at the end of the reaction and are written on the right side of the equation. Next, we need to count the number of atoms of each element on both sides of the equation. To do this, we count the number of atoms of each element in the reactants and then the number of atoms of each element in the products. If an element appears more than once in a compound, we multiply the number of atoms of that element by the subscript. Once we have counted the number of atoms of each element on both sides of the equation, we need to compare them. If the number of atoms of each element is the same on both sides of the equation, then the equation is balanced. However, if the number of atoms of each element is not the same on both sides of the equation, then the equation is not balanced. Determining whether an equation is balanced or not is a crucial step in understanding chemical reactions. Balancing equations ensures that the law of conservation of mass is upheld, and it's essential for accurate stoichiometric calculations.